Hey guys, so today I want to talk to you guys about some basic principles regarding weather, climate, and seasons. Now, as I talk to you about these principles, I just want to emphasize the fact that these are generic principles. They're not very detailed, and sometimes if you try to follow these through in your mind all the way through, it doesn't feel like it works. And that's because weather forecasting, as we know, doesn't really work that well because the weather's kind of unpredictable. So just keep these as in the generic, makes sense area of your brain. Don't try to follow it all the way through because honestly, it doesn't make perfect sense to me. So maybe it won't make perfect sense to you too. So don't worry about it. Okay? All right, here we go. So climate, weather, all begins with the sun, okay? Because the sun warms up the earth, but it warms up the earth unequally. Therefore, we get different weather patterns and climates and biomes and all this other stuff, okay? Now, one of the reasons why the sun warms up the earth unevenly is because the earth is not a cube. Looks kind of spherical, okay? So different areas get heated differently. So if you look at this image here, near the equator, okay, you see that the way that the sun's rays come at the earth, there's a certain amount of rays for a small surface area. So that area is hotter because there's more heat being applied to a small area. But near the poles, because the earth curves and the rays are coming at the same angle, that same amount of heat is spread over a longer area of the earth. Therefore, there's just less heat being applied per unit of surface area. Okay, so that's one big reason why we get different parts of the earth being heated differently. Another big reason is because of the tilt of the earth, which just cooperates with the fact that the earth is heated unevenly. Now, the reason why we get seasons is not because, oh, when we're over here on this part of the sun, the bottom is closer, so it's warmer. And then on the other side, the bottom is farther away, so it's colder. It has nothing to do with distance, okay? The distance change really doesn't affect the amount of heat that we receive very much. It has to do with angle of incidence, okay? With the angle that the sun is coming in. That's how we get the seasons, okay? The angle is fairly consistent at the equator, and then it changes more dramatically as you go toward the poles, okay? So again, seasons are caused by the tilt of the earth, not by distance, okay, from the sun. Okay, so specific heat capacity. Specific heat is just a measurement that takes into consideration the amount of energy required to raise the temperature of a substance by a certain amount, okay? So a substance that heats up really quickly has a very low specific heat. So for example, the metal on the pot, that somebody's cooking in the kitchen, heats up pretty quick, and we all know that. But the handle doesn't. Of course, the handle is probably an insulator. But different substances heat up at different speeds, so to speak, at different rates, okay? Liquid water actually has a very high specific heat. It takes a lot of energy to heat up water, and it loses energy slowly, okay? As opposed to metal or asphalt or cement, which heat up a lot more quickly than water, and also lose their heat fairly quickly, okay? So what this means is that areas with big bodies of water tend to have more consistent weather because it takes longer for the water to heat up in the summer, and it takes longer for the water to cool down in the winter. So just that having a large body of water near land will keep the climate of that piece of land more consistent, okay? Now this also matters for other reasons. So if we think about ocean currents are very important for climate, okay? So if you look at these maps that I gave you guys, Uh, if you consider some of the latitudes of some places in Europe, like Scotland and Denmark and Finland, if you carry that latitude all the way to Canada, you would see that those same latitudes in Canada are pretty not populated, very sparsely populated compared to some of these places in Europe. Okay, so why is that? Why is Canada so much colder at the same latitudes in several places in Europe? Only it's because of the Gulf Stream. So the way that the ocean current works in the Atlantic Ocean is the warm water from the Gulf of Mexico, okay, at the Tropic of Cancer over here, you see in this picture around the Caribbean, travels kind of north and then east towards England and the British Isles. Okay, so that warm current actually helps keep Europe warmer. Okay, because there's just a lot of heat. Okay, that's slowly released by that huge undercurrent, the Gulf Stream. Okay, of ocean water, as opposed to northeastern Canada has the Labrador Current, which comes all the way from the Arctic coming south, and it keeps that area of Canada cold, okay, because that water is cold. If I go back here, and if we think about it too, on the Pacific coast of the United States, I used to live in San Francisco, and you almost never see a person in water in San Francisco. Why is that? Even though it's California, it's supposed to be warm, because the current there comes from Alaska all down the Pacific coast, and the water is very, very cold. Okay, so ocean currents play a big role in climate. All right, a couple other principles, just generic principles I want to cover with you guys real quick before you move on to the next thing, is that hot air rises, okay? And we're going to come back, we're going to cycle back through this concept throughout this unit and the next unit. But when air gets warmer, okay, it spreads, all right, and becomes less dense. Because it's less dense, it tends to rise, okay? And then what happens is the hot air rises, and whatever air is up here and is cool, because it is more dense, it sinks. And what happens is, as the warm air rises, it starts to cool down, okay? And as it cools down, if we're talking not like in a house, but on the earth, as it cools down, it loses moisture. And then what that losing moisture does is it forms clouds, okay? So warm air rises, loses moisture, can form clouds, cold air sinks, and that causes a convection current, causes a movement of air, okay? Now, land has a lower specific heat than water, okay? So what that means is that air near land or over land tends to get warmed up by the heat that's being lost by land, as opposed to air over water. Okay, so air over land tends to be warmer than air over sea. So back in the day when, sailors didn't have GPS and they were discovering the world, sometimes they would be able to spot islands, not just by being able to see land from far away, but they could see clouds even farther away. So if they would all of a sudden in the ocean see a spot that had clouds, and it seemed to be consistent, maybe that meant that there was an island over there. Because remember, land warms up, so the land of the island would get warm more quickly than the ocean, right? But then that air rises over the island, and it loses moisture, and it forms clouds, right? So you can see the clouds from far away. And of course, that helps the little ecosystem of the cloud there, because it'll rain on the island, and then it just keeps, feeding itself. Also, the urban heat island effect, which we talked about this year already. We know how asphalt and cement absorbs heat more quickly. So highly urbanized megacities tend to be hotter than the land that particular area used to be before it was urbanized, because the asphalt and the cement absorb the heat, and it leads to, as we already learned, severe weather events, right? But that's why. The hot air rises, forms clouds, and then if you have that happening all the time with lots of asphalt and cement, like in Tokyo, which we talked about, you get these really crazy severe weather events sometimes. All right, last slide. Talking about high and low pressure fronts. Okay, first of all, a front is a term that just means a large body or clump of air that travels together, and air of the same temperature tends to travel together. So there's typically two kinds of fronts that you hear about, the cold air front and the warm air front. So hopefully what I came up here will help you remember which is which. So cold air front means high pressure. So H for high pressure means happy weather, which means precipitation is less likely. So less likely to have rain or snow or anything like that. Warm air front is a low pressure front, and gloomy weather. So L, low, there's an L in gloomy. There you go. Okay, so you're more likely to have precipitation in with warm air fronts. But most weather events tend to occur in the boundaries, okay, of those high and low pressure fronts. And that is it for our basic principles of weather, climate, and seasons.